mathematics after your third year, okay? So it is very different now, lot of chemistry and physics. Here what I have done was, I have to coat that electrode and make sure it has a very long lifetime, still it doesn't consume lot of energy, and it should efficient in generating the chemicals to kill the bacteria and all those organisms. So I have used some rare metal oxide here. I cannot reveal what is it due to that patenting issue. So anyway, after improving the surface, okay, I can now, what is this diagram? A cyclic voltammogram, you may have not used this before, but after I coat it using the rare metal oxide, active area, surface area has increased a lot. That is why this diagram is bigger. Yeah, I am explaining in very simple manner this. Now before that, before the coating is very small. Now same physical area, your active area is very large. Now what is the benefit of this? Apart from the corrosion resistivity, now this can generate more and more chemicals, oxidants. Okay. Then the stability. Your substrate, the open circuit potential. Now this is a measure of corrosion. If your open circuit potential is very small, like now here it is negative 400 millivolts, okay, it is more prone to corrosion. Now after coating, I was able to increase the open circuit potential to positive value, not very huge, but still 100 millivolts. Okay, now after I increase it to 100 millivolts, now now this type of corrosion won't happen over there. Okay, now this is the end product, laboratory scale. Okay, now this is inside our laboratory in National University of Singapore. This is the reactor. Okay. This is the seawater storage tank. Here are a lot of pumps. Okay. Then this is the small scale, small pilot scale. We did 2 pilot scale studies. This is the small one. The large one was, it is still, they are working on that. Here you can see the reactors. Here the power controllers and some filters and things like that. These are the storage tanks, power box, control panel, and so this is the pilot scale, larger than the laboratory scale. Okay. Now let's come back to our original discussion. Interdisciplinary nature of research, and can we divide it? Okay. Now in my research, being a civil engineer, I have to learn a bit of microbiology, some physics, some material science, and a lot of chemistry. Okay. And finally some engineering. Okay. My major was engineering, but only little bit of it was used. Now, is it impossible? Okay. Now you may thinking, can we do this? Of course you can. Okay. It is not impossible. Now here are some tips for you to practice if you want to be a good researcher. Because nowadays you can't learn one thing and stay in research. That is the nature. Okay. You have to take the challenge. First thing is you have to read a lot in many different disciplines. If you don't like to read, then you will not become a good scientist. Then you may need to learn a lot of new subjects. Okay. Now for example, after I entered the National University of Singapore, I had to learn some science subjects. I have to attend classes in the Faculty of Science. You can't say I was an engineer who took a lot of marks than a normal science student. No, you can't tell like that. You have to learn basics. So you have to change your mindset, okay? Then you have to make a lot of friends. Now I think Dr. Kumari told you many times to do this. Maybe after 10 years you will meet each other again, and one person may be doing chemistry and other person may be doing medicine. Okay? Then you have to form groups. You need lot of people if you want to implement a technology. So now, what this long distance, I think 2 sentences, what is it saying? Telling you. Before 50 years, you have lot of excuses. You didn't have internet, no faxing, nothing, even no photocopiers, okay? But now technology has developed a lot. You can fly from one point to another through internet within few seconds. So, you don't have any excuse saying that I can't, staying in Sri Lanka, I can't do research or things like that. You cannot tell anymore. So, you have to make use of the new technologies. If you have lot of friends in other countries and even in Sri Lanka, and if you can build up a research group, few people from Sri Lanka, some other people from United States and things, from places like that, then finally you will be very fortunate to become a very good scientist. Now here are some success stories. Korea before 50 years, they were well behind us, okay, very poor, but now their life has changed a lot. Then China, 1970s, I have heard my professor who is a Chinese, mainland Chinese, he told at least they didn't have enough to eat, okay, but now they are becoming the world power. So how they change their countries to this, from this to this? They invest a lot of money in science and people work a lot in science and technology. Okay? So you have a part to do. Now few questions for you. First one, now you have to answer, okay? You are a chemist and you want to find a drug for some life-threatening disease. Now you have to name other 2 disciplines to work with. If you are a chemist, can you find a drug alone? Can you answer this question? Like this you won't be able to become a good researcher, okay? You have to talk. Can you remember the good qualities of a researcher? I told you earlier. Questioning. Can you remember that quality? So now you have to answer. Question yourself and answer me. Otherwise I will start pointing out, okay? I will tell you the, say, third guy from the second row, things like that. Okay? Can a chemist find a drug alone? Can? No. Then? Okay, the one wearing a jersey, from this row, this column, 1, 2, 3, 4, 5, 6, 7. Can you tell me one? Can you hear me? Yeah. Otherwise, I'll come to you. Okay. Okay. Stand up and tell one other person. You are a chemist. You are a chemist, and you want to find a new drug. Yeah. Huh? Yeah. So, can you name another discipline you want to work with? Yeah. What discipline? With the engineer, can you do it with the engineer? With an engineer? No. Huh? Sorry, I can't hear you. Yeah, biologist. Okay. Good. Okay, can some other person tell the second one? Biologist. Yeah.
Some scientist.
Scientist in which field? Molecular biology. Okay. Don't you want a doctor in your team? Yeah. Okay. Now, let's move on to the second one. Okay. You are an engineer. Now you are working for a city's water supply. Say in Kandy you are using the river, but in Anuradhapura, where I am from, you have huge tanks. Okay. example, that reservoir which is already polluted. Now, if somebody come and spill some chemical into this reservoir, what will happen? Okay. Now it is contaminated. You can't ask people to drink from that water source. But you can't wait for a long time to rectify that. You need more people to join you. Now name 2 other disciplines you want to work with. Quickly, yeah? We are running out of time now. You are an engineer. Can you start learning biology or chemistry now in this situation, emergency situation? Okay. See the third one from the first row, you. Yeah, microbiologist. Okay. One more. If it is a biological source, yes, a microbiologist. If it is a chemical source, okay, chemist. Now you are a doctor. You have noticed there are a lot of patients with diarrhea recently. Okay? Name 2 other disciplines you want to learn. Oh? Media, yes. Yeah, good. Creative, right? Okay. Few more disciplines. Now you want to, being a doctor, probably you will want to treat them, but besides you need to find the cause for this diarrhea and want to do something. Huh? You may need this engineer to see if the water source is contaminated. What else? But lot of engineers are very weak in chemistry. Now who do you want to work with? Chemist, right? Very simple. Okay, thank you for listening, and now you can ask questions from me. I expect a lot of questions from you.
Make it light. Ask questions. Any language is okay. I mean, Sinhala, Tamil and English. Come on. Get up and ask questions. Come on.
You must be creative, curious, and questioning to become a good researcher. Can you do it like this?
Reading that order that we take from the sea.
Won't the organisms die and then affect the biodiversity?
Yeah, good question. What you mean is now we are killing, right? We are killing what is in the nature. This question is actually there are 2 groups. While International Maritime Organization is asking you to treat water, what is the reason? It is again the biodiversity. You are taking some water from a different environment and throw it away into a new environment, and they become invaders. So that is the reason why we need to treat. Actually, yes, while by doing this thing, we are damaging the nature in a way. But at the same time, if you want to implement your technology, you have to prove the International Maritime Organization it is safe before discharge. You have to check many things. You can't just say, for example, sometimes this electrochemical technology your reaction may produce lot of chlorine. If you dump it, then that particular area may damaged. But the IMO, they don't allow us to do like that. So we have to do lot of safety studies to avoid or to minimize. Actually, we can't avoid this damage. To minimize the damage, there are a lot of other regulations. You can't just bring this set and set inside the ship. You can't do that. There are a lot of other tests to pass. Now this our system, it has already passed on that stage. Yes, there will be an impact. You can't.
Okay, if there are no more questions, shall we thank Dr. Nadeeshani Nanayakkara for her good lecture in the usual manner?